Hello everyone, welcome back to my YouTube channel. Today's video is very special because we are going to train an object detector with TensorFlow 2.3 on Google Colab, and we will train this detector with our own data. So first we will take some of the images and then we will label those images. Then we will set up the TensorFlow environment in our system as well as on Google Colab so that we can utilize the GPU on Google Colab for training up our model. I know that you have faced lot of issues while setting up the system, so I have created a PowerShell script which will all the way set up Python, TensorFlow dependencies, all sort of libraries in your system with a single click. If you are new to my channel, don't forget to press the subscribe button and the bell icon because I used to come up with new updates and new contents about deep learning, machine learning and computer vision every single week. So without waiting, let's start. So I am utilizing here the card images. I took 5 cards and I arranged those cards in multiple ways since I'm going to utilize my laptop webcam for detecting up all these cards. So all these images I have taken from my laptop webcam. Here are some of the images and how I took them. So guys, if you have already seen my TensorFlow setup video, you will know that there are a lot of steps involved while installing the latest TensorFlow object detection API within Windows environment. For clearing out all those steps, I created a PowerShell script which is already available on my GitHub. This PowerShell script is a full-on capsule to install all the dependencies which are required for object detection within Windows. Even though you have GPU installed or not installed within your system, doesn't matter. You will be able to utilize TensorFlow object detection API within your system after running this script. So the good thing about this script that I will keep on updating this script based on the future updates with TensorFlow. So even though you are watching this video after 6 months or 1 year of the upload time, you will be able to run this script and set up your Windows environment for TensorFlow object detection API. And I am also utilizing a system which is very new, not even Python installed within this system. If you have installed Python already in your system, doesn't matter, you can run this PowerShell script and install all the dependencies. So guys, make sure that you have logged in as an administrator within the machine you are utilizing. Otherwise, you will face some issues related to the access. Just right click on the PowerShell script and run it with PowerShell. And once it starts, it will first create a directory within your C drive named as object detection. So guys, once you will start it, it will first install Python 3.7.0 If you want to change to some other version, you can go to the PowerShell editor and change it. Right now, this is the most compatible version. Once it will install Python, it will ask you to install Microsoft C++ Visual Studio, which is a prerequisite for object detection libraries, mostly TensorFlow. And then it will ask you to install Visual Studio Build Tools, and this is also a prerequisite. So this will take up some time. If your internet speed is slow, please wait for some time because it may be downloading the library or the software on the background and installing it. So if you're not seeing anything on the command prompt, you can wait for some time, and based on your internet speed, all the libraries and dependencies will get installed within your system. If you have already installed all the build tools, you can click on repair or just close the dialog box. It will check for the next dependency and install them. After completion of build tools installation, it will install the pip latest version for other dependencies. Then it will install TensorFlow, CV2 and all other basic requirements for object detection. So guys, this tool will not only install these libraries but also set up your environment variables. So this creates some problem whenever you install some new version of Python or some other libraries. You face issues with the environment variables. You need to set it up manually, but in case of this PowerShell script, it will set those up by its own so that you can anytime access Python by just writing Python on the command prompt. Once this is done, it is going to clone the model master Git repo of TensorFlow where all the research and object detection models are saved, and then it will extract and convert the Protos file to the Python executable file. So guys, this all complete process may take from 5 minutes to 30 minutes based on your internet speed. So until and unless this complete command prompts close it by itself, do not try to close it by yourself. So in case anything happens with TensorFlow dependency change or environment issues, I will keep this PowerShell script updated on my GitHub repo. So guys, for testing out that your installation was correct or not, go to the object detection folder within your C drive, then to the models master, then the research folder, then again to the object detection folder. Within this object detection folder, go to the Protos and open this folder. So if you have .protos file as well as the .py file within this folder, it means your installation was successful and you are ready to start object detection model training within your system. So once you are done with taking up the images, now it's time to put up bounding boxes or labeling those images. I am utilizing label-img tool for putting up the bounding boxes on top of. There are other tools available in market, but this tool is good for YOLO object detection as well as TensorFlow object detection. So you can go to the website. I have given link in the description and download the zip file for the latest version. You will get the latest version in the last section of the website. Make sure you are extracting it after downloading. Sometimes when you open this tool, it will ask you for the warning, so you can click on run it anyway, and this is the window you will get in front of you. This window have lot of options like you have open dir, change save dir. So guys, on the open button you can open any folder and select the image. For an example, I am downloading an image from Google for playing cards, and here you can see I have downloaded some of the image, and let's save this image. So we are going to create a new folder inside the object detection folder named as images, where I'm going to put this downloaded image. This is the place where we will keep our training and testing data in future. So let's open this image in the label IMG tool. So I've just clicked on open button. We know that this path is too long. We have to access this path multiple times. So I'm going to add this path to the quick access bar. I can select the create rect box and create a rectangle on top of the image. Then I can give a label to that image. This is pretty simple, guys, and once you press Ctrl S, you can save this labeled image within the same path. Once you save it, you will find an XML file created within the same folder, and if you open this XML file, you will find that this contains the details about the bounding box and the class you created within that image. So here you can see height, width, depth for the image and the label for that image. So this is all, guys. Now I am going to copy all the images which we have taken from the camera within this images folder and then start labeling it with help of label IMG tool. So as you can see, I have labeled all the images, and here's the sample image where I have created bounding boxes on top of these images. So guys, I have used a trick over here because I have 5 cards and I want to train my model with least amount of images. I am taking multiple cards, stick to a diary and showing all those cards at once. In that way, I can get multiple bounding boxes within a single image, and I do not need a lot of image to train up my model. Here, I have taken around 60 images for my training dataset and around 20 images for my testing dataset. On the left hand side, you can see all the labels for the images. So this is the most tedious task to label all those images. If you want to skip this task, there are multiple Kaggle datasets which are available with pre-labeled images. So you can download those zip files from the Kaggle and utilize them for your own object detector. Since we will be doing a lot of here and there with this images folder, so I'm also going to add this images folder to the quick access bar so that I do not have to navigate multiple times to this folder. So once you are done with this, you will have now 2 folders within this images directory, and the one will be train and the other will be test. So keep the same nomenclature for your own dataset, otherwise you may get location errors going forward. After that, you need to create a text file within the same folder named as class-names. So guys, if you are following some other tutorials for object detection, you may not be seeing this method, but I created this method for my own. This makes this process little faster and you will have to invest less time while doing the configuration for the model. So within this class names text file, you need to put all the class names one by one. And here you can see I have kept 5 class names within this txt file. So guys, once you are done with this step, go to my GitHub, download the complete GitHub repo or clone it within the same object detection folder. So here I am downloading the zipped version for cloning up the repo and then extracting this GIF file to the object detection folder. I will be utilizing these three files: generate tfrecord, generate label map, and XML to csv.py. This generate tfrecord is not developed by me, so I took it from the Raccoon Detector GitHub repo. If you want to check out that repo, I have given the link in the description. That is for TensorFlow 1.1 object detection, I think. So as you know that we have that PowerShell script also within the same repo. So I'm not taking that PowerShell script, just taking these three py file to the object detection folder. Now first of all, you need to run these py files to generate the CSV or tfrecord files for training up the model. So I have started the command prompt and then I am writing up cd and the location for this object detector folder. So once you have done this, you can run python xml to csv file, and once you will run this xml to csv.py, you will see there are two files created within the images folder, both for training and testing dataset. Now once you have generated those CSV files, it is the time to generate the tfrecord files. So you can run these two commands to generate the trained record and test record files within the same command prompt. You will get the complete command in the description of this video. So you can just copy this command from the description and run in your command prompt. So if you are successful to generate these tfrecord, you will get this text message that successfully created the tfrecord. You have to do the same for the test tfrecord file. So I have also given the same command in the description. So just run that command and you will be able to see the test.record file in your object detection folder. Now as a final step, you need to generate the label map. So just write python generate _labelmap.py. This is the file we took from the GitHub and I only wrote this code. So you can just utilize this and it will generate a label map file within the images folder. And you will see this label map.pbtxt file in the images directory within object detection. So this is all, guys. Now you have completed all sort of requirement for training up your model. This is the time to download some state-of-the-art models which are newly developed and available for general use. For downloading the latest model, you can go to Object Detection TensorFlow-gpu, and this website contains all new developed models for object detection. Right now for this tutorial, I am utilizing efficient.do 512x512 model, as you can see on the screen. So I'm just right clicking on this one and downloading the model. You will see that after clicking on the download button, you are getting this tar file, and this window is pretty new, so I cannot extract a tar file. So for extracting the tar file, I need to download 7-zip. So I'm going to the 7-zip website and downloading the 7-zip from there. If you have already installed WinZip or WinRAR, you can extract these files by using those extractors. After downloading this file, I have copied this file to the object detection folder, and here I am extracting it now with help of 7-zip. So guys, you have to do 2 times extraction for this file because they have tried to zip it 2 times. So for getting the model out of these zip files, you have to extract it 2 times. After extracting it 2 times, you will get a folder named as efficient.d0 coco17 tpu32. Open this folder. You will see 2 folders and 1 file within this folder named as checkpoint and saved model and pipeline.config file. Now this is the time to put up the configuration file. For getting the configuration file, you need to go to the configs folder, and inside the configs folder you will get tf2 folder, and within that tf2 folder you will get the specific configuration file for training up this model. Go to the SSD efficient file, and I'm going to copy this file inside the images folder, and here is our file. Now we can open this file with Notepad++. So guys, right now this system doesn't have Notepad++, so I'll be doing the editing with simple Notepad. So here is the configuration file. You need to change some basic parameters for this config file so that we will be able to train our own model. First of all, go to the num classes. So guys, based on the classes you have selected within your images, you can put the number over here. In initial, you will get 90 classes written over there. That is for the COCO dataset for which the model previously trained on. So I have 5 classes for these cards. So I am changing it to 5. Once you have changed the num classes, go down and check out this fine-tune checkpoint argument. Here you will see that path to be configured CKPT-0. So here you have just now downloaded that model path. You have to copy the same path and paste it here. So if you will go to the extracted directory that we just now extracted, you will see there is a checkpoint folder. So you have to give the path of this checkpoint folder within the config file. So if you are following the same folder structure from start as I am doing, you will get this path in the description of this video. So just copy this path from there and paste it in this config file. After that, you need to change this fine-tune checkpoint type. So as in previously, you will find that classification is written over here. So you need to change it to detection. Then you will have something called as batch size. So you may find different batch sizes written over here. Right now, since we are going to train it on Google Colab GPU, so I'm changing this batch size to 4. You can even put higher batch size if you are training up for GPU, and if you are going to use your own laptop, you can use smaller batch sizes. Now, going forward, you will get this optimizer, and within this optimizer, so this is an advice to reduce the learning rate if you are using very less number of images. So in case your learning rate is higher, you may find that your loss is going to NAS or infinity after some iteration. I am reducing this loss to e to the power minus 3 and the warm-up learning rate to 0.001. So you can even go for lower amount of these losses based on the number of images you are going to keep inside the training folder. Going down, you will see that there is a label map path. So here you have to give the path of label map.pbtxt. If you are following the same tutorial, this path sits on images. So I have given this path in the description. Just copy this path from there and paste it within this label map path. Same label map path you have to give within the lower argument where it is asking for test label map path. So just give the same label map path over here. You need to give the input tfrecord path. We know that our tfrecord files are sitting within the object detection folder. So you can just give train.tfrecord for the training side and test.tfrecord for the testing side of this config file. So just as a recap, we will check out if we have put all arguments correctly. So I'm starting from the lowest one. In the last, we have put this test.tfrecord. Then we change the label map path for the input side, for the training side, and the input path train.record for the training one. After that, we have reduced the warm-up learning rate to 0.0001 and the learning rate base to 8 e to the power minus 3. In the start, we gave the fine-tuned checkpoint path. So this path, make sure you have given correctly. And as the starting argument, we change the number of classes. So guys, I just did a recap because this is very important to give correct configuration for model training. Otherwise, you will face errors while training up the model. So guys, there are a couple of arguments that these libraries are not placed correctly. So I'm going to create another object detection folder within this object detection folder. This is important because while doing the development of TensorFlow object detection, there are some paths which are not correctly placed. Till now, I don't know if they are going to correct it in future or not, but till now I have seen this problem with TensorFlow that these paths are not correctly placed. So we are going to create another object detection folder within this object detection folder. I'm going to copy all the folders and files from the current object detection folder, leaving the images and the model folders. Okay, so here is the step. Just copy all the folders and the scripts within this object detection folders and paste it inside the object detection folder you created within this object detection folder. So this will set up all your paths wherever these object detection modules are called. You have to create another training folder within this object detection and copy the label map.pbtxt and the config file you just now edited, SSD efficient at D0512 cross 512 Coco 17-TPU. These two files we have to just copy from the images folder and put it inside the training folder. After that, you'll have to start training up your model. So you have to run this command which is showing up in the window. Also, I have given this complete command in the description. So this is for the training of the model. Here you are calling up the tf2 training.py and then giving the arguments for the config file for saving up the models over here. So I got an error after running this script named as no module named Elvis. So what I did, I just ran pip install lvis and it has installed that dependency. You are not going to face this error because I have already added this pip install Elvis in the PowerShell command where it installed this Elvis library in the start itself. So once you are done with this, you have to just run the object detection model by typing this command in the command window. Make sure while you are with. So after running this command, you have to wait for some time. This will take up some time while it will configure your model, compile your model, and your training will start. So guys, right now, if you have GPU installed within this system, it will start using that GPU. But we are going to train this model within the Google Colab. So we will utilize the Google Colab free GPU for training of the model. So we are going to just take this object detection folder and create a zip file, and then we will upload this zip file to our Google Drive. So here you can see I'm compressing this object detection folder, and now I'm just logging in to my Google Drive and creating a folder named as TensorFlow-2 or TF2. So you can see that I'm uploading this complete zipped file to this TF2 folder. This will take up some time because if you have a bigger training dataset, the zip file will be very big. In my case, I have around 80 images only, so it is smaller, around 119 MB I think. So that's why it is pretty faster to upload to the Google Drive. Once you have done uploading this zip file to the Google Drive, you can open the Google Colab to start the model training. So I am just renaming the Colab file as in training TF2 object detection model. So first of all, we need to mount our Google Drive. So for mounting the Google Drive, the command is very simple. You have to import drive from Google Colab. Then you have to just write drive.mount, then content.drive. This will give you a link for your Google Drive and also ask the authorization code. So click on this link and log into your Google Drive. There you will get a passcode mounting up this Google Drive to your Google Colab. So here you can see that I was able to mount my Google Drive. Now it is saying mounted as content.drive. Now I'm just doing a small check that which files are saved. So I'm just writing colon then ls. So this will give you the list of files which are saved within that directory. The next part is the files we have uploaded to the Google Drive. We have to unzip those files. So I am utilizing the unzip command and giving the zip file location as an initial and the location where I want to extract it. Once you will run this command, this is going to take up some time to extract all the files. So all these commands you are going to get into the description. You can just copy these commands from the description and extract the files. Now, if you will go back to the tf2 folder, you will see that this object detection folder is created and you have all the files which you have modified within your local system are placed now in Google Drive. Actually, when I'm right now running these files, there are two dependencies which are required for training up these object detection libraries within Google Colab. So you have to type pip install tfmodel-official and then pip install tf_slim. So this is going to install both the dependencies within your Google Colab. So this is not permanent, guys. Next time whenever you are logging into your Google Colab, you need to again install both the libraries. So guys, this is the time to utilize the GPU. So I'm going to the edit command and I'm changing the hardware accelerator to GPU. So after this, we will be able to utilize the GPU for training up the model. But once you change the instance type, you need to again mount the drive because the connection will be lost. So you have to again mount the drive, run the mount drive command and again go to the Google Drive and take the access code, paste it here so that you will be able to mount the drive. As I told earlier, you need to again install the dependencies. So I'm again running these tfmodel.official and tfslim to install these libraries. So for running the command within the same directory, you have to write percentage, then cd, then give the location of the object detection file. So guys, here this percentage cd is called the magic command because this will help you out to navigate to multiple directories within your Google Drive. After you run this command, you will be able to reach to the object detection library, and here you can just run the command which we used for training up our model in the local system. So only the thing you have to press, you have to give the colon because that will help you to run these notebook commands into the command prompt, I can say. So here, after running the command, you can see I am getting this no module found Elvis error. So this is the same sort of error we got while running up on the local system. So you have to install these dependencies. So you can just do colon pip install Elvis and this will install this dependency. So once you have installed Elvis, now we are running this Python train command that we ran on the local system with a colon, and you will see that slowly the training will start. Even though we are running on GPU, this is object detection and may take huge time for training. I left my notebook running for 2 hours to reach to a very good accuracy and very low loss. So guys, after having a very low loss, you need to generate the inference graph. You can actually do not utilize the model directly. So you have to create the inference, then only you will be able to use your model for detection. So for generating the inference graph, the command is very simple and I have given this command in the description. Once you will run this command, this is also going to take some time for generating the inferences. As in final, if your inference generation is successful, and if you will go back to your Google Drive and within the inference graph folder, you will find there are 2 folders named as checkpoint, saved model, and there is a file named as pipeline config. So this is the final inference graph, which is a trained model and will be utilized for detecting the objects. you need to download this inference graph folder. As you are downloading from Google Drive, it is going to create a zip file for this folder, and once you download this folder, you have to extract these files within the object detection local folder. Now guys, you are all set for object detection. So this is the time to utilize this trained model for detecting some of the objects. After putting up the inference graph, you have to go to the object detection folder. Then there is a folder named as Colab tutorials. So open that folder and you will get this file named as object detection underscore tutorial ipynb. So this is a notebook file. You have to copy this file and paste it in the research folder. So guys, make sure you are pasting it to the research folder, not within the object detection, because the path within this notebook are actually accessible from the research folder only. Otherwise you may get errors if you are pasting it to the object detection. So we are just copying it and pasting it to the research folder. And once you have copied it, go to your command prompt, write cd, then the path to the research folder, and you will be able to reach to the research folder. Then type Jupyter notebook so that you can edit the notebook file. So once you have opened the Jupyter notebook, in the notebook you will see that it is object detection API demo, and you have something called as setup. So you have to skip some of the part because all these setup things is being already taken care by the PowerShell script which we run in the start. Skipping everything, you will reach to the import section where you are importing NumPy OS and other dependencies. Run this command shell and run the second command shell where you are importing the object detection modules. Then run the patches, run the loader part, go to the loading label map. So here guys, you know that our label map is actually different because we have created for our own which have 5 classes within that. So we will give the path for label map pbtxt over here. Here I am giving the relative path. If you want to skip some of the section, go to the description and copy the path from there. After running this cell, your all label map will be loaded and you can get into the detection part. In the next part, you have to give the path to the images on which you want to detect the object. So you will see that inside the object detection folder, you will have one test images folder. So copy some of the images within that folder on which you want to detect the object. Also, you will get an error named as pathlib is not defined. So import pathlib, and if you are getting some error, you can go to the command prompt and type pip install pathlib. So here we are already within the research folder. So I'm going to delete the first part of this path starting from object detection. So guys, this is the time to load up our model. Right now you can see that here it is given model name is equal to SSD MobileNet V1 Coco. So comment this out and we will be loading up our own model with a simple command tf.savedmodel.load. Inside this savedmodel.load, you need to give the path to the inference graph and the saved model directory. So this inference graph, you know that we have taken up from the Google Drive where we trained our model. Since you are loading it first time, this will take some time to load up and you may see some of the warnings also. You can ignore the warning and go to the next step. Now you can run the additional cells and you will find this run inference for a single image function. Run this code. As a final, you will have one shell where you are running this model on the given images. So you can just run this cell. As an output, you will see that the object you wanted to detect are now getting detected within the image. Here you can see that I am taking up 2 cards on my hand and this object detector is detecting both the card correctly. If you want to run this inference on and detect images on the webcam or the live webcam, so you will get a notebook file within my repo or that you have already cloned it. So you will find that object detector ipynb file within that repo. Use that file and run the command line by line as I am running it here. As in final, when you will run this cb2 command, you will find that your webcam is running and you are able to detect object with your trained model. You may face some of the errors if basic libraries are not installed within your system. So in case you find any error within these lines, go to the command prompt and type pip install that dependencies which is missing there. Most probably you won't get any errors in case there is some change with the TensorFlow repo or TensorFlow dependencies, then only you will face some error, but I will try to fix those ones by changing the PowerShell file which you are using at the start. With that guys, we were being able to train up our model on Google Colab with the latest version of TensorFlow. So if you have liked the session, don't forget to press the subscribe button and the bell icon. You have given a lot of love to me. I have seen in my past videos, your comments are amazing. You guys are actually following up and learning a lot. I can see it moving pretty quickly. Thank you so much for such a support guys. I will catch up with you on my next video where we will come up with some new technologies which are evolving right now around us. So with that, I will meet you in my next video. Till then, bye bye, take care.